The chair shook. Above the dam, the reservoir held enough water to bury the valley below, where tens of thousands still slept through the tremor. The operator grabbed his chair arms and waited for concrete to crack. That's how dams failed. The wall splits, water punches through, everything downstream disappears. But the concrete held. Instead, the ground outside began to roll. A slow wave passed through the hillside itself, solid earth turning to something like thick soup. He watched land flow toward the reservoir. The dam wasn't cracking, the dam was sinking. The crest dropped before his eyes, water creeping closer to the lip. Somewhere below, families woke to coffee and radios, unaware the wall above them had only 5 feet left. 5 feet of packed dirt between their mourning and a flood that would erase the valley. The operator reached for the phone. Would anyone answer in time? The dam had stood for nearly 60 years. Built between 1912 and 1915, it was an earthfill embankment, a mountain of packed soil holding back a lake above the San Fernando Valley. The builders chose speed over caution. They used hydraulic fill, mixing soil with water and pumping it through pipes as a slurry. The mixture settled where it fell. The water drained away. The soil stayed behind, fast, cheap, and loose enough to kill. The process left the dam's core saturated, its grains barely touching, held apart by invisible pockets of trapped water. For decades, this skeleton held steady. The reservoir rose and fell with the seasons. Children grew up beneath it. The dam became part of the landscape as permanent as the hills around it. Inspectors walked its crest and found nothing wrong. The soil looked solid enough. It felt solid underfoot. But the water trapped between its grains was a secret passenger, waiting. Every earthquake California had ever known had been a rehearsal. The engineers never imagined the ground itself could betray them. What would happen the first time the ground really shook? The operator's chair still vibrated. He gripped the armrests and waited for the jolt to pass, the way tremors always passed. They didn't. The earthquake's waves punched through the hillside and into the saturated sand beneath the dam. The grains tried to shift, to rearrange, but the water between them had nowhere to drain. So the pressure in those pockets climbed. Higher, higher still. The water pressed upward, forcing the grains apart. Engineers call this pore water pressure, and as it rose, something critical vanished, grain touching grain. The force holding the soil together, effective stress, dropping towards zero. Now the sand stopped behaving like a solid. It became a heavy liquid. The upstream foundation, which had borne the dam's weight since 1915, suddenly offered no more resistance than wet sand at the tide line when a wave washes over it. And above it sat 40 feet of reservoir, patient and immense, pushing outward with all its weight. The operator felt the shaking. He didn't yet know that the ground beneath his feet had already begun to unmake itself. How far would the slope slide before the shaking stopped? The answer came fast. Within 90 seconds of the first jolt, the upstream shell broke free. Not gradually, not in pieces. As one massive block, 800,000 cubic yards of earth peeled away from the dam and plunged into the reservoir. The crest dropped 30 feet in a single heave. Cracks ripped open along the top, wide enough to swallow a man's leg. The upstream face slid 150 feet sideways, burying itself in the water it was meant to hold back. And then, impossibly, the shaking continued. Aftershocks rolled through the hills. The reservoir, still nearly full, now lapped against a crest lowered to within 5 feet of the top, 5 feet the thickness of a tall man lying down. That thin wedge of cracked earth and trembling soil was all that stood between the water and the valley below, where tens of thousands of people slept through a morning they did not yet know would change everything. The operator clung to the railing. His dam still stood, but it was mortally wounded and the ground beneath it had not finished moving. The operator's radio crackled. Engineers were coming. He didn't let go of the railing. By dawn, men in hard hats stood at the crest and stared at what the earthquake had done. The cracks gaped. The reservoir shimmered 5 feet below their boots. One engineer dropped to his knees and pressed his palm flat against the dirt. It felt wrong. Too soft, like wet sand at the edge of a wave. They didn't need a meeting. Every outlet, every valve, every spillway gate was opened. Water had to leave faster than it ever had. Meanwhile, sirens began to wail in the valley below. Loudspeakers on trucks crawled through neighborhoods, telling people to move, to climb, to get clear of the flood path. Tens of thousands of them, families grabbing children, abandoning breakfast, staring up at the hills where their dam stood wounded. The ground rumbled again, a smaller shock, but the crest shuddered. The water inched higher against the lowered wall. They were racing the aftershocks now, and no one knew how many more were coming. The reservoir receded, inch by inch. The waterline dropped and the valley below breathed again. But H. Boltonseed was already driving toward the dam. He arrived from Berkeley with Kenneth Lee and Izzat Idris, carrying equipment most dam builders had never needed. Their mission was not repair, it was accusation. They drilled into the upstream slope and pulled out cylinders of sand, brown, granular, damp, ordinary enough to any eye but theirs. In their laboratory, they placed samples on shaking tables and watched something impossible happen. The sand grew liquid, not gradually. One moment it supported weight, the next it flowed like heavy water. They named what they saw flow liquefaction. The dam had not failed because it was poorly shaped or too steep. It had failed because the very soil it stood on could erase its own strength when shaken hard enough. Seed's team published their findings, and quietly engineers around the world began to wonder, how many other dams were sleeping on ground that could turn to liquid? Seed's paper landed in 1975. Engineers in Japan, Italy, Chile, anywhere the ground shook, saw their own dams staring back from its pages. Hydraulic fill had been cheap and fast, now it looked like borrowed time. Within a decade, new codes forced a question no one had asked before: can this soil liquefy? Engineers learned to read the ground like weather, how loose the sand sat, how high the water table rose, how hard the next earthquake might strike. Dams got retrofitted, reservoirs got drawn down before shaking started. The ground that betrayed one February morning became the teacher that warned thousands. Because the wall of water never came, because some operator called evacuation and some engineer opened the valves, the lesson survived. The near miss wrote itself into concrete and code, but codes age, memory fades, and the earth keeps its own counsel. Beneath reservoirs and skyscrapers, bridges and ports, the same saturated sands still wait, patient, invisible, ready to forget they ever held shape. How many places have we built, certain the ground beneath us is solid, never knowing if tomorrow's shaking will ask it to flow? The lower San Fernando Dam still holds back its reservoir today. Its crest was rebuilt, its slopes reshaped, its foundations drained and densified, but the original soil remains beneath, a quiet archive of the morning when solid ground forgot its name. On that day, the shaking sealed the drainage paths within the hydraulic fill. Water had nowhere to escape. Pore pressure climbed grain by grain until it matched the weight of the earth above. Effective stress, the very force that locks soil into solidity, dropped to nothing. The grains floated. 800,000 cubic yards of earth slid into the reservoir as if poured from a bucket, because for those 90 seconds the ground had become a heavy liquid. The 5 feet of freeboard held, the valves opened, the valley emptied. And so the lesson was learned without a single life lost to the water that never came. The dam stands at dawn now, its surface still, its repaired crest catching the light. While below in the dark between grains, the memory of that morning lingers like a warning whispered by the sand itself. If stories like this make you look twice at the ground beneath your feet, consider subscribing. There is always another hidden mechanism waiting to be unearthed.